320 hertz. And this is E for any music people interested. Well, first, I need to know what my open-closed first harmonic wave looks like. Open-closed. I have a node at one end, an antinode at the other. First harmonic looks like this. 1/4 of a wavelength equals the length of the tube. Now, what is the wavelength of my 320 hertz tuning fork? I know the frequency, I know the velocity, so I can use V equals F lambda in order to figure out my wavelength. 340 meters per second equals 320 hertz. Back to wavelength. Wavelength is 1.06 meters. So that is a full wavelength. Now, the first harmonic doesn't represent a full wavelength. First harmonic represents 1/4 of a wavelength. 1/4 of my wavelength, 0.06 meters, equals the length of my tube. So the length of my tube is 0.27 meters. So if I create this tube length, 0.27 meters, I should get a standing wave pattern. And I'll know that because my sound will be amplified. And we'll do that in a second, but I want to see if I can find out where the second harmonic would be. How long would I need to make it in order for the second harmonic? What does a second harmonic look like? Still closed, opened. Closed here, antinode at the open end, and I add a node in the middle. So how many waves do I have? 3/4 of a wave. I know the wavelength already. Just because I'm in my second harmonic, that doesn't change the velocity, nor does it change the frequency of my tuning fork. So I know the wavelength of the standing wave already. So how long does my tube need to be here? .795 meters. So I should hear a harmonic at 0.27 meters, amplified sound, and then I should hear another amplified sound if I move the slide back to 0.795 meters. And we will listen for those.